Welcome to the next lesson in this chapter, Module Constraints. Here's a quick rundown of what we are going to cover inside of this lesson. We're going to talk about module constraints, which is also the title of this lesson. I'm also going to discuss the concepts of cohesion and coupling and how they change over time and affect our software development process. We are also going to talk about module communication and module data isolation. Let's start with a quick reminder of what is a modular monolith. It's an architectural pattern that structures the application into independent modules or components with well-defined boundaries. All of this sounds nice on paper, or in this case on the screen, but how do we actually enforce this in our design? This is where module constraints come in. So our modules inside of the modular monolith must follow a few constraints that we are going to define now. The first constraint is that we need to enforce the logical isolation between our modules. The second constraint is that modules must talk through a public API. And the last constraint is that the module data must be isolated in the database. Now, the second and third point about module communication and data isolation also help us achieve logical isolation between modules, and you will see why this is the case when I show you how we are going to implement the communication between our modules and the various ways that we can achieve data isolation between our modules. An interesting question that comes out of all of this is, why are we doing this in the first place? And the reason for enforcing so many constraints on our modules is so that we can control coupling. Coupling, at least when it comes to software, is the degree of dependence between one module to each of the other modules in the system. Let's illustrate this through an example. We have a couple of software components in this diagram, and the arrows between the components represent the flow of communication from one component to the other. As we introduce new components into the system, it also increases the number of components that communicate to each other and in turn depend on each other. So in other words, we are increasing the degree of coupling inside of the system as the system grows. So this type of behavior is very common inside of a monolith system, and you will see that over time the degree of coupling between your components is going to only keep increasing unless you find a way to control it. This usually starts out simply. I'm going to call just one method from this one component to get some data, but what could happen is this component can end up calling some other component to get that data, and before you know it, you have a very complicated cycle of dependencies. And where this becomes even worse is when one component decides, I'm not even going to talk to this component to fetch the data that I need, I'm going to query it directly from this component's database table. This is probably the worst kind of coupling that you can introduce inside of a monolith system, and is going to severely slow you down, and it could even end up introducing some nasty bugs that are hard to track down. If we don't find a way to control the amount of coupling in our system, we end up with what is called tight coupling. And this basically means that when you make a change in one component or one module in your system, this is going to cause some unintended side effects in the other components in your system. Tight coupling between the components significantly increases the complexity of your system and makes it harder to evolve over time. So what we really want is to achieve loosely coupled modules inside of our modular monolith. Now, how we can control the degree of coupling between the modules is by only communicating between modules using the module's public API. And another way to control coupling is to isolate the data for each module inside of the database, which means there is no sharing of data directly between two unrelated modules. But let's take a closer look into these two concepts. So we're going to explore module communication and data isolation between our modules. We are going to start with module communication first, and I'm just going to briefly cover the most important concepts when it comes to module communication. There is going to be a complete chapter later into the course that will deal with module communication in depth, and we're also going to implement the various kinds of module communication patterns, but for now, let's just stick to the basics. The modules inside of a modular monolith are loosely coupled by design. This is because the modules only talk through a public API. Now, there are two ways how we can implement a public API. We can do this using method calls, which are in memory, very fast and efficient, or we can implement this using messaging, which means that we have asynchronous communication at the cost of increased complexity. Let's say that we want to implement communication between two modules using method calls. And for example, one module needs to invoke a specific operation inside of the other module. The module that we want to call is going to expose a public API that will allow us to call this operation. Now, because we are talking about a method call, a public API could just be a method on a specific class. In practice, you are actually going to expose just a public interface. Let's say it's some sort of a service interface. Maybe you could even call it a module API, but the general idea is that you will have a public interface that exposes a set of methods that other modules can call. The implementation of this interface is going to be encapsulated inside of the declaring module, and at runtime, we are going to use dependency injection to replace the interface of the public API with the actual implementation when some of the modules tries to call the public API. So I said that a public API could be an interface with a respective implementation, but it could also be a query or command object that you send with something like Mediator. It doesn't really matter what tool you use. How you can identify that you are using method calls is because you are going to be doing request response. In other words, you will have to wait for the module to respond to your query or command, which is a form of tightly coupled communication between two modules because the module calling the public API of another module has to wait to get back a response. This also means that we have temporal coupling in this example because we are assuming that the module that we are trying to call is available. Now, inside of a monolith system, this will usually be the case, but what happens when you extract the dependent module into a separate service? At this point, the public API could remain the same, but you can no longer use a method call, and you will have to replace a method call